This is welcome to the lecture number 76. This is last lecture of this chapter circle, but very important sum. Both the sums are very lengthy, natural. Their weightage are also very big. So, in case if this sum or the next sum, that is 25th, will be asked in the examination, their weightage will be of 4 marks each. So, okay, anyway, so we will find it is question number 24 and figure number 3.102. In this figure, they have given us two circles which are intersecting each other in point A and E. BC is a tangent to the smaller circle while DC is tangent to the larger circle. And we have to do quadrilateral ABCD. Quadrilateral ABCD as a cyclic quadrilateral. We are going to use property of cyclic quadrilateral that opposite angles PAD plus angle BCD is equal to 1 angle. So I join this AD and AD also. So by joining this, I would like to prove that angle BAD plus angle BCD is equal to 1. Okay, let's begin the proof. We will surely find, we have to find out BAD. So angle BAE, angle BAE, angle BAE is equal to angle. Now BAE, you will notice this is an inscribed angle that is equal to half RB, as well as angle EBC, or I can say angle DBC. So angle DBC is equal to half measure on BE. You will notice BD is secant and BC is tangent. So by tangent, secant angle, the measure of angle is also equal to the half of intersected R. So that is equal to half measure R. But combining these two reasons, we can say angle BAE is equal to angle DBC label it as 1. You can say angles in the alternate segments. You all know the combined result of inscribed angle theorem and tangent secant angle theorem will give us a new step here, the angles in the alternate segment. So similarly, you will find angle DAE. Try to understand. Angle DAE. Angle DAE is equal to half RDE. That is equal to angle BDC is also equal to half RDE. This is secant. BD is secant, DC is tangent. So by tangent secant angle theorem, angle is equal to half RD, and by inscribed angle theorem, EAD is equal to half RD. So again I am going to write the same thing, that DAE, angle DAE is equal to angle DAE, this angle is equal to angle BDC, is equal to angle BDC is equal to half major arc DE. Therefore, angle DAE is equal to angle PBC. Result reason same angles in the alternate side. Angles in the alternate side. Now you find we have to get angle BAE, and we can get angle BAE if we add BAE plus DAE. BAE plus angle DAE. If we add these two angles, we will get angle BAD. So adding 1 and 2. Adding 1 and 2. Adding 1 and 2. Because our final result is to prove BAE plus BCD is 1. So adding 1 and 2. BAE, left hand side of 1 plus left hand side of 2 minus 3 is equal to angle TBC. Plus angle PBC. Right hand side of 1 plus right hand side of 2. But if you look at this, BAE plus DAE, if we add these two angles, BAE, this angle, plus DAE, you will be getting entire angle BAD. So angle BAD is equal to sum of these two is BAD is equal to BBC plus angle BDC. Label it as A. Even when we add these two angles BAE and DAE, we got to BAE. So by angle addition property, we can say that by angle addition property. By angle addition property. Okay. By angle addition property. Now look here. With BAD, we have decided with BAD, I have to take BCD. If I get a result in such a manner that BAD plus BCD is equal to 180, then naturally I claim that opposite angles of this quadrilateral are supplementary. Therefore, BADC is a cyclic quadrilateral. So I'm going to add now. So adding angle BAD plus BCD. So adding angle BCD on both sides of A, on both sides of A. So angle BAD, with which we are going to add BCD, is equal to angle DBC, or stated you can take BCD plus angle DBC plus angle BDC. Label it as B. Our final aim is to prove quadrilateral BADC is a cyclic. For that, we are going to prove BAD plus BCD is equal to 180. So BAD, if I and BCD. Then on right hand side also BCD with DBC plus BDC. Please look at in triangle. In triangle BCD. This is a triangle. BCD is a triangle. In triangle BCD. In triangle BCD. Angle BCD. Angle BCD plus angle DBC. DBC plus angle BDC. BDC. This is equal to 180 degree. Sum of the angles of triangle. Sum of the angles of triangle is 180. Okay. Please try to understand here. Angle BAD plus BCD. After adding BAD with BCD on right hand side, BCD, same angle, we have added here also on right hand side of ring. So BCD, DBC as well as BDC, we have not changed them. We have written them same. But you will surely notice it's a triangle. So BCD plus DBC plus BDC, that is equal to 180. This is our results. So substituting C in B, substituting C in B. Okay. So you will find left hand side C, angle BAD plus angle BCD. But right hand side now becomes 180. Right hand side is nothing but this side. And sum of all of these angles is equal to 180. That is, since angle BAD, since angle BAD and angle BC are opposite angles, of quadrilateral, very important, of quadrilateral ABCD. These are opposite angles of quadrilateral ABC. Then quadrilateral ABCD is cyclic. Because opposite angles of cyclic quadrilateral are always supplementary. That is what we have to prove. So here you will find question number 24. This is question number 24, in which we have to prove that quadrilateral ABCD is a cyclic quadrilateral. I repeat again, angle BAE, this angle, half arm B, angle CED is also half arm BE. Therefore, these two angles are congruent, but combined result is called as angles in the alternate side. In the same way, you will find that angle BDC, that is equal to half R DE. DE is secant, BC is tangent. Angle EAB is equal to half R ED is cut angle. So these angles combined is called as angles in the alternate side. So adding this 1 and 2, you will be getting angle BAE plus angle DAA, that is equal to angle BAD. So here you will find that angle BAD. The right hand side is DBC plus BBC. So adding angle BCD on both sides of A. So BAD as it is, BCD will add it over here along with BAD. So in the same manner, BCD plus BBC plus BBC plus BBC. This type of the BCD plus BBC plus BBC. But if you look at the figure, then you will find that BCD plus BBC plus BBC are the three angles of triangle BC. And sum of the three angles of triangle is 180. Very simple. So I label it as result C. Then I say that substituting C in B. So left hand side, BAD plus BCD will remain as it is. But BCD plus BBC plus BBC, that is equal to 180. So here you will find BAD plus BC is equal to 180. But what is BAD? If you look at the position of BAD and BCD with respect to the quadrilateral ABCD, you will find these are opposite angles. And since their sum is 180, they are supplementary angles. And if opposite angles of any quadrilateral are supplementary angles, then it is called as cyclic quadrilateral. So please look at this sum carefully, try to understand this sum carefully. Weightage is of 4 marks. Now, we are going to solve the last sum, that is question. The last question of this chapter. So here, same sum we have done in previous things. Simply revision of all these sums. If you know the previously done sums carefully, you can apply the same theory over here also. It's very important chapter, very lengthy chapter. The last, that is question number 25. Okay. Fine. So here you will find triangle is the name of the triangle is ABC. Name of the triangle is ABC. Then you will find in this triangle ABC altitudes are drawn. Namely, AD is altitude on BC. Then you will find CD is altitude. Sorry, CF is altitude. CF is altitude on AB and okay. And next to that is B is altitude. Down. This is also 90. Question asked is to prove that point O is in center. This is point O. Point O is in center. To prove that O is in center of triangle DB. Fine. O is in center of triangle DB. Given here AB perpendicular to BC. Next to that is CF is perpendicular to AB, and you will find this DE is perpendicular to AC. This is given. All these things are given, and we have to prove that. Prove that O is in center. O is in center of this triangle. Please try to understand this carefully. In center of triangle. In center of the triangle. In center means center of an incircle, and to draw incircle, it is very important. Point of intersection of angle bisectors of that triangle. I repeat again. Point of intersection. Point of intersection of angle bisectors. So, if we prove that this AD is angle bisector of FDE, as well as BE is angle bisector of FED, as well as CF is angle bisector of EFD, then we can say O is in center. O is in center of triangle TEF. Again I am telling you that in center is a point of intersection of angle bisectors of this triangle, because it is a center of incircle. So supposing if I draw by taking O as a center, it will touch to the sides of DF, DE and EF. So in short, to prove that, right, to prove that, I'm writing it again, to prove that AB is a bisector of angle. A is the bisector of angle FDE. Then you can say, again we try this, right? So A is a bisector. Likewise, CF is a bisector of angle DFE, and BE is a bisector of angle FED. Okay, fine. Now, what we are going to do, if we prove one AD is angle bisector of FDE, that is sufficient. Then straight away we'll say similar. Then we'll say similar. So now my aim is to prove AD is angle bisector. AD is angle bisector of FDE. It is angle bisector of FDE. Please try to understand now very, very carefully, dear students. Okay, proof. In triangle, okay, in triangle FOB, in triangle FOB, and triangle FOB, it is all about this FOB, and triangle EOC. Please focus on these two triangles, FOB and EOC. These two triangles are very, very important right now. So you will find it in triangle FOB, angle F is 90. In triangle EOC, angle E is 90. Angle FOB is congruent with angle EOC, vertically opposite angles. So first of all, I write angle F is equal to angle E. Angle F is equal to angle E, that is equal to 90. Because you will find BE is perpendicular to AC. In the same way, CF is perpendicular to A. CF is perpendicular to A. I have already written these two triangles. Be careful about it. So, angle FOB, is equal to angle FOB is equal to angle EOC. Vertically opposite angles. So now I am going to use theory. If two angles of two triangles are congruent, then the remaining third pair of the angles are also congruent. I repeat, if two angles of two triangles are congruent, then remaining third pair of the angles of triangle are also congruent. So I am saying, therefore angle FBO, is equal to angle FBO is equal to angle ECO. Angle EC. Third pair of the angles. This is very important step. FBO is equal to ECO. Why? Because two angles of two triangles are congruent naturally. The third pair of the angles is going to be congruent. So angle lect, now I write lect. Angle FBO is equal to angle ECO, that is equal to x. Okay. So I am going to call it as x. This will be as x. Now please try to understand, dear students. Very important thing you have to understand, and that is very, very important. Very, very important. Quadrilateral OECD. Quadrilateral OECD is cyclic. Very, very important. Please try to understand. OECD is a cyclic. Why? Opposite angles are supplementary. Reason is angle D plus angle E is equal to 180. Is equal to 180. OECD is a cyclic, and now it is very, very important reason that this is angle Y. So you will find angle X. Angle X is equal to angle Y. Angle X is equal to angle Y. Very, very important. That is angle ODE. Angle ODE is congruent to angle OCE. These angles are called as angles inscribed in the same arc, because in case if we draw an arc on this OE, then y is equal to half arc OE, as well as x is also equals to half arc OE. Very, very important thing to understand this. So x is congruent to y. So here we can say angles inscribed in the same arc. Angles inscribed in the same arc. Angles inscribed in the same arc, very, very important. Fine. Similarly, you will find BFOD. Similarly, you will find, or even you can say O, right? Try to understand. OFBD, 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 quadrilateral. FBD is cyclic. Why this quadrilateral is also cyclic? This will be OFBD is cyclic. Why? Angle D plus angle F. Angle D plus angle F is equal to 180. Opposite angles. D plus F, that is also equals to 180. 90 plus 90. But these are opposite angles for quadrilateral BFO. Now, therefore, now what happens? If this is angle X, try to understand. If I have taken this as angle X, then this is also equals to X. Or X is congruent with Y. So if I take this as X, I'll get this as X. Please try to understand. These are also angles inscribed in the same arc. If I draw arc over OF, then X is equal to half arc OF, as well as this X is also equal to half arc. So very, very important thing. So you'll find this. I'm going to label this as one. So angle FBO, angle FBO is equal to angle FBO, angle FBO, that is equal to FBO, that is equal to X. That is equal to X. Try to understand FBO, that is equal to FBO, that is equal to X. And this is right in the same arc, or I write here angle FBO is equal to FBO is equal to FBO. Angles inscribed in this thing. Angles inscribed in the same arc. Very, very important. This is 2. From 1 and 2. From 1 and 2. We have already proved this x is congruent with y. Now we got this x is also congruent with 1. Very important reason we got. Therefore, angle FBE is equal to angle angle FBO is equal to EBO, angle EB. From 1 and 2. Reason is angle X is equal to angle Y. Reason is angle X is equal to EB. FBO is equal to EDO, X is equal to 1. But we have already proved this X is congruent with this X. This is also X. This is Y. So X is congruent with Y because this Y and this X is congruent. Correct? X is equal to 1. But angle FBO is equal to EDO shows that AD is a bisector of FDE. AD bisects angle FDE. Similarly, we can show. Similarly, we can show BE bisect FED. Bisects BE bisects FED. And CF bisects angle EFD. Similarly, we can say, right? That is what it is. Therefore, O is a circumcenter. Incenter. O is incenter. Triangle. Okay. So please try to understand. Not so difficult. O Only you have to understand basic things. What is that? FBO is a triangle. Fine. EOC is also a triangle. These two are vertically opposite angles. Fine. If these two are vertically opposite angles, this angle is 90 and this angle is 90. Then what happens? Two angles of FBO are respectively congruent with two angles of ECO. Clear? So what happens? Third pair of the angles are also congruent. So X is congruent with this X. Fine. Then next to that, EOBC. EOBC is cyclic. Why it is cyclic? Opposite angles are supplementary. Therefore, this angle and this angle are angles inscribed in the same arc. These are the angles inscribed in the same arc. So that is how you will be getting X is congruent with what? Likewise, F and D. FODB. FODB is also cyclic. So this X and this X is also congruent, because if I draw arc of a circle, then naturally I get these two angles are inscribed in the same arc, and measure of each one of them is equal to half arc OF. Therefore, these two are also X. Now, if X is equal to this X, then you find X is equal to Y, are congruent, finish. So this X is also congruent with Y. This X is also congruent with Y, because this is X, this is X. This X is congruent with Y because these are inscribed angles. But this X and this X are congruent because they are angles in the inscribed in the same arc. So X is congruent with Y. If X is congruent with Y, AD is a bisector of FDE. Likewise, then you can say similar. Okay. And then actually O becomes in center of triangle DEF. Okay, this last sum quite difficult to understand. You can say in critical side, but not so difficult also. Important facts: FB, TO is a cycle, OP, CD is a cycle. Third pair of the angles of these two triangles congruent. That's sufficient. And then inscribe. Okay, my dear students, we have finished here. Very important as well as very lengthy chapter, you can say, circle. Weightage for this chapter is maximum, of course. Contents are maximum, weightage is also maximum. You have to understand so many things. Inscribed angle there. Tangent, secant angle there. As well as very basic, that tangent is perpendicular to the radius. Very popular there, opposite angles of cyclic, quadrilateral, or supplementary. These all are very important things to understand. So please see that you have to revise this chapter every now and then. Now I am going to finish this lecture number 76 here. Wishing you all the best for this chapter, for revising this chapter. That is what I would say. Because not so easy to understand all these things without revisions again and again. So this chapter requires to be revised again and again, and very lengthy chapters. Thanks a lot for listening to this lecture number 76. In this last 3 to 4 lectures, I have done only 2 sums in a lecture. The reason is same, that to make you understand in detail. That was a main. Thanks a lot. God bless you all. From the next lecture, we are going to do a last and very easy chapter, that is construction. Thank you very much.